Imagine going to sleep, knowing that your entire country depends on a wall. Not a military wall, not a border wall, a wall holding back the ocean. Now imagine that wall suddenly failing. Within hours, entire towns disappear beneath seawater. Thousands of homes vanish. Roads become rivers. Farmland turns into an inland sea. Power stations shut down. Families climb onto rooftops, waiting for rescue that may never come. For most nations, this would be remembered as one of history's worst natural disasters. For the Netherlands, it became the beginning of one of the greatest engineering projects ever attempted. A project so massive, it permanently changed the relationship between humanity and the sea. Today, millions of people live safely below sea level. One of Europe's busiest ports operates every single day. Entire cities continue to thrive because of an engineering system that few people outside the Netherlands have ever heard of. It's called the Delta Works, a network of gigantic storm surge barriers, massive dams, artificial islands, and moving steel gates, designed to stop the North Sea itself. Many engineers consider it one of the greatest civil engineering achievements of the modern world. But to understand why it had to be built, we first have to return to one terrifying winter night. When the sea came back, the Netherlands has always lived with water. Nearly 1/3 of the country lies below sea level. Another large portion sits only a few meters above it. For centuries, the Dutch relied on dikes, canals, windmills, and pumping stations to keep the ocean away. It worked, most of the time, but nature doesn't negotiate. Every storm tests every barrier. Every high tide pushes against the coastline. Every winter reminds the Dutch of one simple truth. If the defenses fail, the sea returns. By the middle of the 20th century, many flood defenses had protected communities for generations. Some had survived countless storms. People trusted them, perhaps too much, because while cities expanded, industries grew, and millions of people settled in vulnerable areas. Many of the old flood barriers remained largely unchanged. They had been built for another era, an era before modern climate records, before massive coastal development, and before anyone imagined what one extraordinary storm could do. That storm arrived in 1953, and within a single night, it changed Dutch engineering forever. On the evening of January 31st, 1953, a deep Atlantic storm moved toward the North Sea. Powerful northwesterly winds pushed enormous volumes of seawater toward the Dutch coast. At the same time, an unusually high spring tide raised water levels even further. The two forces combined into something catastrophic. Along much of the southwest coastline, the sea rose higher than many engineers had ever recorded. Then, the dikes began to fail. First one section collapsed, then another. Soon, dozens of breaches opened across the flood defenses. Seawater rushed inland with incredible force. Entire villages were swallowed in darkness. People woke to the sound of crashing water against their homes. Some escaped to rooftops. Others climbed into attics, hoping the water would stop rising. For many, it never did. Communication lines failed. Roads disappeared beneath floodwater. Rescue teams struggled to reach isolated communities. By the time the storm finally passed, more than 1,800 people had lost their lives. Over 70,000 residents were evacuated. Nearly 200,000 hectares of farmland had been flooded with salt water. Thousands of homes, farms, and businesses lay in ruins. The disaster shocked not only the Netherlands, but the entire world. Yet what happened next would become even more extraordinary, because instead of rebuilding exactly what had been lost, the Dutch made a decision that almost no country had ever attempted. They would redesign their entire coastline, not for the next storm, but for the next 100 years. The morning after the flood, the destruction was impossible to ignore. Entire communities had vanished beneath muddy water. Fields that had fed families for generations were now poisoned by salt. Bridges were gone. Roads had disappeared, and one question echoed across the country. How could this ever be allowed to happen again? Within weeks, the Dutch government assembled the nation's best engineers, hydrologists, and coastal experts. Their mission wasn't to repair the damaged dikes. It was far more ambitious. They were asked to redesign the entire southwest coastline of the Netherlands. The result became known as the Delta Plan. Instead of defending hundreds of miles of exposed shoreline, engineers proposed shortening the coastline itself. The idea sounded almost impossible. If several wide estuaries could be closed with massive dams, the total length of vulnerable sea defenses would shrink by hundreds of kilometers. Fewer openings meant fewer weak points. Shorter coastlines meant stronger protection. It was one of the boldest engineering strategies ever proposed, not simply resisting nature, but reshaping the geography of an entire nation. Parliament approved the project. Construction began, and what followed would take decades to complete. Building a dam across a calm river is difficult. Building one across the open sea is something else entirely. The North Sea never stops moving. Powerful tides race through the estuaries twice every day. Strong currents constantly reshape the seabed. Storms can arrive without warning. Every hour construction crews spin offshore. They were fighting nature itself. Traditional methods simply wouldn't work. So Dutch engineers developed entirely new techniques. Specialized vessels transported enormous concrete caissons weighing thousands of tons. Massive rock barges dumped millions of tons of stone onto the seabed, creating stable foundations where none had existed before. Precision surveying equipment ensured every structure aligned perfectly, despite waves, wind, and constantly shifting currents. Sometimes, construction crews had only a few hours during slack tide to position giant components. Missed that window, and they had to wait for the next tidal cycle. Progress was measured in centimeters. Mistakes could cost months. Yet year after year, the barriers slowly grew. What had once been open water began transforming into one of the most advanced flood defense systems on Earth. But one location presented a challenge unlike any other: the Oosterschelde. And solving that problem would require one of the most extraordinary engineering compromises ever made. Originally, engineers planned to close the Oosterschelde estuary completely, just like the others. On paper, it was the safest solution. But there was a problem. Closing the estuary would destroy a unique saltwater ecosystem. Fishing communities depended on its tides. Marine life depended on its changing currents. Environmental groups argued that protecting people shouldn't mean destroying nature. For years, the debate divided the country. Eventually, engineers proposed an idea that had never been attempted at this scale. Instead of building a solid dam, they would build a storm surge barrier. Under normal conditions, the sea would continue flowing naturally through enormous openings. Fish could migrate. Tides would continue. The ecosystem would survive. But when a dangerous storm approached, gigantic steel gates would close, temporarily sealing off the sea. It was an engineering solution that balanced safety, economics, and environmental protection. The project became known as the Oosterschelde. Even today, it remains one of the most remarkable movable storm surge barriers ever constructed. It proved that great engineering isn't always about choosing one side. Sometimes, it's about finding a way to protect both people and nature. Building the Oosterschelde was unlike anything engineers had attempted before. This wasn't a traditional dam. It was a machine, a structure designed to remain open most of the year, yet transform into an impenetrable sea wall within hours. The barrier stretches nearly 9 kilometers across the Oosterschelde estuary. At its heart stand 65 enormous reinforced concrete piers, each weighing up to 18,000 tons. Between them hang 62 massive steel gates, some wider than a football field. Constructing these pieces on land was only half the challenge. Each pier had to be transported into open water, then lowered onto the seabed with extraordinary precision. The North Sea offered no second chances. Strong currents constantly pushed against the floating structures. Even a small positioning error could prevent the gates from operating correctly. Engineers developed custom-built lifting ships, computer-guided positioning systems, and new underwater surveying techniques to place every pier within centimeters of its intended location. When completed, The gates remained open almost all the time. Twice a day, the tides continued flowing through the barrier, preserving the estuary's natural ecosystem. But whenever extreme storm conditions threatened the coastline, the gates could be lowered, turning the open estuary into a solid defensive wall. It was one of the first flood defense systems in history designed not simply to stop the sea, but to cooperate with it. While the Delta Works protected much of the southwest, one challenge still remained: Rotterdam, home to one of the busiest ports on Earth. Every year, tens of thousands of cargo ships travel through its waterways. Closing the river permanently wasn't an option. International trade depended on keeping the channel open, but leaving it open also created a dangerous weakness. If a major storm surge entered the river, millions of people, billions of dollars in infrastructure, and one of Europe's most important economic hubs would be at risk. Engineers needed a barrier unlike anything ever built. The solution became the Megaproject storm surge barrier. Instead of a fixed dam, the system uses two gigantic floating steel gates. Each gate is approximately 210 meters long, longer than 2 football fields placed end to end. Most of the time, they rest inside massive dry docks along the riverbanks, allowing ships to pass freely. But when forecasts predict dangerously high sea levels, the gates slowly swing toward the center of the channel. Water fills giant ballast tanks, causing the floating structures to sink onto the riverbed. Within a few hours, the river is completely sealed. Once the danger passes, compressed air removes the water. The gates float back to the surface, and normal shipping resumes. It's one of the largest moving structures ever created. And remarkably, the entire sequence can operate almost entirely on its own. The Delta Works doesn't rely on human observation alone. It depends on information. Across the Dutch coastline, thousands of sensors continuously monitor the environment. Sea level, river flow, wind speed, atmospheric pressure, wave height, rainfall. Every second, new data flows into sophisticated computer systems. These systems compare real-time conditions with decades of historical records and advanced weather models. When forecasts indicate that water levels could exceed safe limits, the decision-making process begins automatically. For barriers like the Megaproject, the computer calculates whether the incoming storm presents a genuine threat. If the predicted water level reaches the critical threshold, the closure sequence starts. Operators continue monitoring every stage, but the technology is designed to react faster than humans alone ever could. Because during an extreme storm, minutes matter. A delayed response could expose millions of people to catastrophic flooding. By combining engineering, meteorology, automation, and artificial intelligence, the Netherlands has transformed flood protection into one of the world's most advanced real-time infrastructure systems. The sea is always watched, every hour, every day, every year. For many engineering projects, completion is the finish line. A bridge opens, a tunnel begins carrying traffic, a dam starts generating electricity. The project is complete. The Delta Works is different. Engineers often describe it as a living system, one that must constantly evolve, because the ocean never stops changing. Sea levels continue to rise. Storm patterns become less predictable. Rivers carry greater volumes of water during periods of extreme rainfall. A flood defense designed for the 20th century may not be sufficient for the 21st. That's why the Netherlands continuously upgrades its coastal defenses. Dikes are strengthened. Pumping stations are modernized. Storm barriers receive new sensors, new software, and improved mechanical systems. Engineers inspect critical structures year-round, using drones, underwater robots, laser scanning, and satellite monitoring. The goal isn't simply to repair problems. It's to identify them before they ever become dangerous. Today, the Delta Works operates as one of the most closely monitored infrastructure systems on Earth. Because the Dutch understand one simple truth: flood protection is never permanent. It is a responsibility that must be renewed, generation after generation. The Delta Works wasn't built to become famous. It was built so an entire nation could survive. But its influence quickly spread far beyond the Netherlands. as rising seas and stronger storms began threatening coastlines around the world. Engineers looked to one country that had already spent centuries solving the problem. Dutch engineering firms have advised projects in the United States, the United Kingdom, South Korea, Vietnam, Indonesia, and the Middle East. Many of the flood control strategies used today, from movable storm surge barriers to advanced pumping systems and integrated coastal planning, were refined through lessons learned on the Delta Works. After Hurricane Katrina devastated New Orleans in 2005, Dutch water experts were invited to help improve flood protection strategies. Cities such as London and Venice have also developed large-scale storm barriers based on similar engineering principles. No two coastlines are identical, but the philosophy remains the same. Accept that water cannot always be stopped, then design systems that can safely control it. The Delta Works prove that protecting millions of lives requires more than stronger walls. It requires smarter engineering. For thousands of years, civilizations feared the sea. Storms destroyed ports. Floods erased cities. Entire communities disappeared beneath rising water. Humanity could rebuild, but it could never truly control the ocean. The Netherlands challenged that belief, not with a single dam, not with one barrier, but with an entire network of engineering working together. The Delta Works isn't just a collection of concrete, steel, and machinery. It's a promise that millions of people can live safely in a place where nature never intended them to. Every gate that closes before a storm, every sensor measuring the tides, every pump quietly moving water through the night, represents decades of knowledge earned through both innovation and tragedy. The sea is still there. It still rises with every tide. It still pushes against the coastline every single day. The Dutch know they haven't defeated it, because nature is never truly defeated. Instead, they've done something far more remarkable. They've learned how to coexist with one of Earth's most powerful forces. And perhaps that's the greatest lesson the Delta Works offers the world. The future of engineering isn't about conquering nature. It's about understanding it, adapting to it, and building systems capable of protecting generations yet to come. Today, millions of people wake up each morning below sea level, go to work, send their children to school, and live ordinary lives. Most rarely think about the giant barriers, the hidden pumps, or the silent machines protecting them, because the greatest engineering achievements often go unnoticed. Not because they aren't extraordinary, but because they work exactly as they were designed to. The Delta Works didn't eliminate the threat of the sea. It did something even more important. It gave an entire nation the confidence to build its future where the ocean once ruled. And in doing so, it became far more than an engineering project. It became one of humanity's greatest demonstrations of resilience, innovation, and the determination to shape a safer world.